Good day to all. Today we are going to discuss the quiz 5, which is about the topic was Introduction to Chemical Processes. In this topic, we have discussed like the different type of the chemical processes, such as batch process, transient process, steady-state process, continuous process, semi-batch, semi-continuous, and etc. So, and also we talked about each type of like the process, their examples, and how they are used in industrial life. So let's get started with this quiz. We have like 4 or 5 questions, but at the end, you'll get some introductory knowledge about these chemical processes. So the first question, match the correct and relatable ones. We have 4 different, as you see, the main statements here, and 4 different like given type of the process. The first one is steady state, second one is transient, batch, and continuous. So in general, batch and continuous, they are process type. So what is batch process? Actually, the batch process is, in general, the feed is supplied beforehand, like at the beginning of the process, and we don't have to supply the new feed while the process is going inside of this vessel, reactor, and etc. So, and also we get the product at the end of the process. It means that if we want to choose one of them, like from these 4 different statements, we need to focus on one thing. So we are supplying the feed at the beginning, and we are like removing the product at the end of the process. We are not doing it intermediately or intermittently or like continuously. But in the other case, like continuous process, in the continuous process, it's a little bit different because we are like supplying the raw materials, and also we are removing the product in each continuous, like the hour, minute, or something, the time of the period. Therefore, the main difference between them, when we are like writing that mass or energy balances, we are considering that in the batch process, it will be kilogram, for example, in terms of the mass, it will be kilomole in terms of the mole. But when it comes to the continuous, it will be divided by something like time. For example, kilogram per second, kilogram per hour, kilogram per minute, or something. Also, for example, in terms of the mole, it will be kilomole per hour, kilomole per second, or something. So let's see, feed and product are supplied and removed in some period of time. So as we said, in some supplied and removed in some period of time, it will be continuous process. Next. Feed and product supplied at the beginning and then removed at the end of the process. It will be batch, as we said. So next, we need to discuss like steady state and transient, or with other name like unsteady state process. The steady state processes are, so during the like any conversion, during any process occurring inside of the reactor, distillation column, any separation unit, and all other process equipment. So our process variables should be like stay the same. It should be kept constant. What does it mean? So if you're like controlling the reactor in terms of the temperature control, let's say your reaction should be going around like 300, right? So it should be kept the same, like 300, because your reaction is adjusted to 300. But like if you are if there is an increase in the temperature, for example, 350, 400, or 500 something, it means if it's like exothermic, they will be huge amount of heat release, and this reaction will be like the runaway reaction. It's undesirable. Therefore, we say that the exothermic reactions, and also if there is a huge amount of release of this reaction heat, it will be very undesirable, and therefore we need to keep the temperature constant. So that we said that in the steady state, the process variables should be kept the constant. But when it comes to transit or unsteady state, there is always fluctuations in the process variables. So, and also controlling this state, it will be very difficult for us. That's why in the plants, they are trying to always reach the steady state process rather than the transient. So let's see, none of the process variables are changed. So it means this is steady state, but all process variable can change during the process occurring. This is transient or unsteady state. Next one. So what's consumption? So consumption is, we said that in the general mass balance equation, we have inlet, outlet, consumption, generation, and accumulation, right? What is inlet? Inlet is enters through the system boundaries. This will be inlet. So outlet is leaves through system boundaries. That's also correct. This is inlet and outlet. So produced within the system and consumed within the system. Generally, the generation is produced within the system and consumption is consumed within the system. And in the non-reactive systems, we have only inlet and outlet and also accumulation. Additionally, we don't need to consider this consumption or generation terms. And also we have additional accumulation term. Accumulation is like the build-up of the some additional like processed products inside of the process equipment. So, but it is in this question, it was asked to find the consumption. This is consumed within the system. Next, how to avoid buildup in the pipelines or process equipment. One word is enough. So we said that the buildup is like the accumulation within the system, and this is one of the most dangerous state for process equipment because your production rate will be decreasing, and this is undesirable for us. We need to like avoid this buildup within the system. So before like starting up any equipment, before starting up any pipeline, they are trying to purge all pipelines, all process equipment in order to like get removed as impurities, any buildup or accumulation. This will be purge or purging. Purging. Next one, you can see the red sign on the figure. Look at right side, looks like start. Okay, we have this figure, separation, absorption, distillation, storage. These are units, and this is block flow diagram, as you see. Reaction unit and purification. Okay, we have look at right side, looks like start. This one, red sign. How this process stream is called in process engineering. Okay, so first of all, let's see the distillation. We have the outlet, purification unit is gone. After purification, it is going to reaction unit. Okay, reaction unit again is inlet to the distillation unit. So it means most probably outlet and inlet like a relationship. We can say that yes. We can say that they are trying to like get some additional product. So maybe it at the first side there will be 25 or 30% conversion, but then purified and sent to the reaction unit again and sent to distillation unit again. It will be there will be the increase in the conversion. Therefore, mainly it's called like recycle stream. In order, our main aim is to increase the conversion and not to lose our valuable products. It will be recycle stream. Recycle. Around distillation unit, how many inlet and outlets you can see, right? Only numbers. For example, if you see one inlet and 4 outlets, write 14. Okay, 1, 4. Okay, it's clear. Around distillation unit, here is a distillation unit, right? So let's see what is the inlet. Separation, it has 1 inlet, right? And 2 outlets. 2 outlets are removed from this block. Okay. Absorption, it has only 1 inlet, no outlet. So now distillation. Distillation has 1 inlet, second inlet. Okay, second inlet. Distillation has 2 inlets, 1 outlet, second outlet, as you see. Okay, it means distillation, 2 inlets and 2 outlets. It will be 20. That's all from this quiz. In the next class, we'll also discuss some additional chemical processes and also like the very detailed form of the mass balance and also combustion reactions and etc. Also, don't forget to watch our practical assignments explanations in our playlist. I'll also put it here to watch by yourself and also solve these questions by yourself and then watch the videos. So because in each class, this is like the theoretical knowledge checking, but the practical side is more important. So that's all from this quiz, and let's meet in the quiz 6, the chemical processes mass balance. Goodbye.